Some of the other features and how they actually apply to the model are whether or not we have the solids turned on for displaying all of the elements within the model. If we turn off the solid display, we'll just see the wireframe of the model on the screen. We can turn on and off the nodes. In this view in the lower left, you can see we're just displaying all of the elements in the model. If we turn the nodes on, you can see all of these red dots are endpoints, and endpoints are used to define strakes. An endpoint runs from one end of a module to the other and has all the various divisions for that module along the length of that line. The blue asterisks are additional nodes, but both of those types of nodes are controlled by this display button for turning nodes on and off. As I mentioned earlier, the black and white button is just for controlling the color of the background, and by default, when you open Maestro, it's the white background is the one that's shown. The ability to shrink elements, so you can see sort of inside the model. You can also use cutting planes and other things for viewing inside the model, but the shrink elements is a nice quick way of getting a view of some of the interior components. It's also especially useful like when you are defining your tanks. You grab a group of elements to define a tank boundary, and you want to make sure that you don't have any additional internal structure inside the tank. We really only want the outer boundary of the tank because it'll have a pressure side associated with it that liquid in the tank is going to apply pressure to. If we have some internal components in there, the tank may have baffles in it or something like that are technically modeled in the Maestro model and in the ship. But in terms of creating a tank, we really only want the outer boundary, and that's what's going to take the pressure of the fluid in the tank. So this shrink elements is very useful for once you've defined your tank, you can quickly shrink elements and spin it around a little bit to see whether or not there are any leftover internal pieces in there. There's an ability to set parts transparent, and this works on a module by module basis. But you can, if you click this button, you can click on a graphical module in there, and it'll turn the associated module in the tree transparent. This operation can also be done on items in the tree directly using a right click to bring up a menu in that tree window. And there's an associated unset part transparent, which will bring it back to a solid color. This button to display the stiffeners on and off, and those stiffeners are for embedded stiffeners when you're using the orthotropic plate elements. You can see in this one, the OSV model, I guess, is transversely stiffened, so you can see how frequent the stiffeners are there. So there is no internal stiffener layout on any of the strake elements, but you can see there are stiffener layouts on some of the elements on this transverse bulkhead. And then this toolbar button will control the display of the water plane, turning it on and off. And the water plane is defined for a given load condition and can either be a still water plane or any type of wave. You can have a wave in the head following sea condition or at some angle, and control where exactly the crest and trough are, as well as the amplitude of the wave. And when we go to display the model, as we mentioned earlier, there's a hierarchical pattern to the models in Maestro. And at the top level will always be this, and it's referred to as a substructure, top. The rest of these can be named arbitrarily, and it helps to have some, I guess, fairly informative naming structure. If we go back to this sample OSV model and expand it, it's a little easier to see things here. You can see at the top, which is the default, we have a substructure for the bow, the mid-body, the stern, and the superstructure. And in order to get them to be displayed in order, we used a number. So substructure 1, substructure 2, 3, and 4. Within each substructure, which is basically like a folder with files underneath it, there are substructures and modules. And within this substructure, we have module 1, module 2, 3, 4, 5, and 6, as well as the frames that it represents. So module 1 contains the structure from frames 1 to 3, module 2, frames 3 to 5, and so forth. And as I mentioned earlier, when you right-click in the modeling area, you get the main, I guess, context window here. If you hold the control key down and right click, you get the construction geometry. When you're in the parts tree view, if you right click on one of these items, you get a completely different context menu. And you'll see a couple of the items in here are, say, set transparency on or off. So we can set transparency on for that module. And you can see this bow module became transparent. We could unset it from here or use the unset transparent button and then click on it to change it back. The important thing here is the difference between view parts, current parts, and there's also a command to set both the view part and the current part. And what those represent, and they're shown by this icon in the tree, is the highlighted item, the view part, is basically what is going to be displayed in the modeling area. Anything below the view part will be displayed. The current part is essentially the active module that you're editing. So when you go to modify or add structure, it's going to be selected from whatever is the current part. They can be the same, or you may want to display, you can have the entire ship displayed. You make the top level your view part, but we're currently editing the module 1 from the mid-body substructure. To locate this one in the hull, an easy way of doing that is just turn transparency on. That's like, okay, there's where the extents of our module is. That is our current module. Now you can query anywhere in the model, but if you go to edit, and we'll use one of these pre-processing toolbars over here, we can select, to edit a strake, and we'll click on one of these strakes to edit it. If we were to try and edit a strake that's in a module that's not current, it won't let us do it. We can only edit within the current module. And you can easily change what the current module is by right-clicking on a different part, although it's not as clear. If you had built the model, you'd probably be very familiar with it, and you would know which module was which in each of these. But if you are opening this sample model and you're not intimately familiar with how it was built, it's sometimes easier to use these buttons to say, I want to set this part current, and it'll automatically be selected in the tree. Likewise, if I were to go near the stern and select one of those, actually that one was still in the mid-body, but it's a little easier to graphically select those sometimes. And if we want to see what the extents of that module is, we can use the transparency. There is a toolbar option to turn on and off the entire parts tree as well as the groups tree. Later on, we'll be getting into defining groups. These modules are the breakdown of how the ship was constructed, but the groups are somewhat arbitrary. We create a group and we select elements from the entire model, and they can span module boundaries and substructure boundaries. And those groups that we define will be placed in the groups tree. And there are a number of different types of groups, and we'll get into that later. General group is just an arbitrary collection of elements from the model. A module group is an entire module or several entire modules all contained in a single group. A volume group is what is used for defining tanks. You can also have nodal groups, and there are also plate groups. Plate groups might be used for defining an area that you are going to distribute a cargo mass on the deck. And the nodal group would be used for something like creating a nodal mass representing, say, an engine. You would create a node out in 3D space, you put it in a nodal group, and it's that group that gets the weight applied to it. And then later you can connect that node down to the model structure using an RBE element.